Suppose I add 1 tablespoon of sugar into water taken in a beaker. Obviously, after some time, the sugar get completely dissolved in the water because the force of attraction experienced by the constituent particles of the sugar is weak or less. That means you know that this water or liquid they are easy to flow and move wherever they want. So when a sugar particles are added to this water get collided with these sugar particles, and this collision weakens or break the force of attraction between the sugar solid particles, and eventually the sugar get dissolved in that liquid, giving us sugar solution. Instead of sugar, if I'm adding certain amount of sand into this water, it will not dissolve, right? That means it gets settled at the bottom of the beaker. As such, sand will not dissolve in the water because the force of attraction between the sand particle is very strong, and that cannot be broken by the just collision of water particles. That water particles cannot break the force of attraction between the sand particles by just colliding or by just moving in between them. Now, as in the case of a sugar particle, if I am adding some potassium permanganate into water, potassium permanganate is a chemical. It is very intensely dark pink colored chemical. If I add some amount of potassium permanganate into water, initially it will have a light pink color. Gradually, the entire water will become dark pink in color, because as the water is in continuous motion, they collide with this potassium permanganate particle, making the force of attraction between them weak, and eventually the potassium permanganate get dissolved in this water, giving us deep pink color. Okay, so from this experiment, it is evident that the liquid or the water particles are easy or free to move. Now, consider in a closed room, I sprayed some perfume from one corner. Obviously, after some time, the fragrance of the perfume will be spread throughout that closed room, because the gas particles in that perfume are free to move wherever they want. And that is the reason why we are feeling the fragrance in that entire room. So, gas particles are free to move wherever they want. So, when we compare solids, liquids and gases, the movement is possible at the highest for gases, then comes liquid, and then comes the solids. And we are stating this freedom of movement on the basis of their interparticle spacing. In the case of gases, the constituent particles, the space between the constituent particles or the interparticle spacing is very large, so it is very easy for them to move wherever they want. In the case of liquids, they have interparticle spacing, but it is less when compared with that of gases, and it is large when compared with that of solid. So it can flow to some extent. While we are talking about the solids, their interparticle spacing is negligible, making them not move anywhere.